I might get started. Here we go. I might get started because I have a couple of slides before Rhonda comes. That means everybody gets an opportunity to bump on in and not hear me do the boring stuff. So welcome to the TARC webinar. Today it's going to be conducted by Rhonda Jones. We'll get to that in a minute. It's about how to store data in Excel and to do it effectively so you don't annoy statisticians, which is a really super important point.
Or yourself, if you're going to analyse yourself.
So for those of you who don't know about TARC, TARC is a collaboration between 5 HHSs in northern Queensland. So we've got Cairns and Hinterland, Mackay, Northwest Torres and Cape and Townsville. It also is a collaboration with the Northern Queensland Primary Health Network and the Queensland Aboriginal Islander Health Council, as well as James Cook. There's our website on that. If you haven't had an opportunity to go and check out the website, looking at all the background, all the webinars that we've done this year, or the training options that are still available for you, please go ahead and do so. Our research themes are fourfold. We have service delivery to the triple Rs and the Aboriginal Torres Strait Islander populations. We have innovative health workforce models. We also work with non-communicable diseases and high regional prevalence and infectious diseases. So for today's webinar, before we get going, just a couple of little bits and pieces. Please just mute your microphones until the Q&A. Rhonda, do you want Q&A anytime or at the end? I forgot to ask.
I don't really mind.
There we go. As long if it's a small group, we can do any time. That's fine. Usually large groups, I leave it till the end.
Yeah.
You can put, I love the typo. You can put your questions in the chat if you like. If you're just too shy and want me to have a look at that, that's fine. I can read that out for you. Or feel free to raise your hand function and we can call you out. So that's me. Rhonda, would you like sharing while I introduce you? So today's webinar is Professor Rhonda Jones. She's an emeritus professor at James Cook Uni. She's also the senior statistical consultant for the TARC, Study Design, Epidemiology and Biostatistical Support Services, known as SEBS. Well done, Rhonda. It's on my screen. I swear, Rhonda has a couple of lifetimes worth of experience in research. And today she's going to share her pearls of wisdom with you. So over to you, Rhonda.
Well, I don't know about pearls. I mean, rather, grubby bits of oyster, perhaps. Okay. So what we're going to be talking about is what almost everybody does, which is storing research data in Excel. And there's a reason why everybody does it, and it's because Excel is in many ways very convenient and very, very good for data storage. There's actually many spreadsheet packages out there, and some of them are even free, but almost nobody's heard of any of them except Excel. And that's really not too surprising because these days it's actually not too expensive. And there's no doubt that it's the most powerful of the spreadsheet packages that you can use. Now, the thing about spreadsheets in general and Excel in particular is that they are really good for storage, but they're not great for doing analyses. There are many reasons why they're good for storage. One is just how much you can put in there. So Excel can hold a lot of data. You can have more than 1 million rows, you can have more than 16,000 columns, and of course you can have multiple spreadsheets. So some people have data sets that are too big for Excel, but it's not common. If you know how to drive Excel, it's got a lot of really useful functions for editing and manipulating data, including creating new variables that are derived from the old ones. And it can actually handle basic descriptive statistics pretty well. And it can do some of the simpler tests pretty well too, but enough that you can actually use Excel, and we have to teach very basic statistics courses at university level, but it isn't, and it doesn't pretend to be designed for the range and complexity of analyses that research data usually needs. So you need more. So overall, Excel's a pretty good option for data entry and data storage. And when you do need to transfer your data to a specialist statistical package like SPSS or R or whatever, any statistical software that you can imagine is going to have the capacity to read an Excel spreadsheet. So it's actually a good place to start in terms of storing data, even if you are going to have to move the data to statistical software, or somebody else is going to have to do that for you somewhere down the track. So what's the problem? Well, actually, there are two major problems. The first one is that it's possible to be far too creative in how you store data in Excel. So the thing about statistical software is that it's really quite rigid and unforgiving about how it expects to receive its data. Really, really fussy. But Excel is going to let you store data pretty much any way you like. And that means that if you get even slightly creative, the way you store data in Excel may turn out to be totally incompatible with how a statistical package needs to get it. So that's the first problem, is Excel doesn't force you, or even attempt to force you, to store your data in a way that a statistical package requires. So very often it won't be. So that's the structural problem. The other problem is really not Excel's fault at all. It's just that if, for example, you're entering data manually into any sort of electronic storage, that's really one of the world's more tedious jobs. And that means that when that's happening, people make mistakes. So it's almost guaranteed that, especially in large data sets, there will be errors in the data. Sometimes a lot of errors. And often the mistakes that people make on data entry will be harmless and even invisible to somebody, to a human who is looking at the data set, but disastrous when it comes to actually analysing the data. So to summarise that, it's very easy to make mistakes in data entry. If the data aren't structured properly, then your data set is going to be incompatible with the software you need to do statistical analysis with. And if you don't know how to do it, restructuring the data and fixing data errors could take weeks of work, if the data set is large. I mean, if it's a little data set, then it's not a problem. But if you've got a data set with hundreds or thousands of cases, then it is not fun to fix that data set. Given that these days people are more and more using routinely collected data to ask research questions, getting really big data sets has become much simpler, but that doesn't guarantee that the routinely collected data is without error. So it's restructuring the data and fixing data errors that are the issue. If you're with Townsville Hospital, then you've got the data lab to access the data for you and to make sure that it's structured properly as well, which is a huge plus. If you aren't there, then that may be more of a problem. But in general, the smaller errors, the individual data errors, are often things which need actual discipline expertise to fix safely. And that means it's often something that you're going to need to do yourself. As this last point makes, that fixing data errors is never fun, but Excel can actually make it a good deal easier for you. In other words, Excel may make it easier to make errors, but it also makes those errors easier to fix. Okay, so just to summarise that, I mean, basically, if you've got a bad structure and a lot of errors, then that makes the analysis of the data slow and messy. And from the point of view of whoever does the analysis, a beautifully structured data set with no errors is going to result in a very happy analyst. The more problems there are, the more grumpy your analyst is going to feel, and that means the less willing to be helpful they're going to feel. So fundamentally, it's worth everybody's while to try and get data sets that are analysed. Okay, so what I'll do now is let's look at what is a very simple and quite hypothetical data set, which is awful. It doesn't have every problem that's possible, but I put in a few. We'll walk through what the issues are, and also then use the same data set to look at ways that Excel can help you fix the errors. Okay, so this is this hypothetical data set. So what we've got is a hypothetical disorder. So this is a pseudo clinical example, and this disorder passes through 3 stages as it develops, which we'll call stages 1, 2, and 3. Treatment of this disorder is more likely to be successful if it's diagnosed early. So the question is which this data set is intended to answer, is whether people who have this disorder and are from rural or remote locations tend to be identified later than people from larger communities. In other words, is the diagnosis of this disorder in time to have satisfactory treatment worse for rural and remote patients than it would be for somebody who lives next door to a hospital. Okay, we will also assume for the purpose of this exercise that some of the attributes of the patient, like gender and age and body mass index, might have an influence on the capacity to diagnose the disorder. So those things will probably need to be taken into account when the data are analysed. And what all of that means is that the analysis can't really be done in Excel, or the complete analysis can't be done in Excel, and the data is going to have to be transferred to statistical software. So let's have a look at how the data is at the moment. So we've got each of the colour codes. Essentially, the first group is a set of patients who were successfully diagnosed at stage 1. The second is a group diagnosed at stage 2. The third is diagnosed at stage 3. And what we want to know, initially, at least, is summarised in the little boxes at the side, which says, okay, how many patients were diagnosed at each stage, and what proportion of them were rural or remote. And it looks, with these appallingly hopeless sample sizes, I might add, but we're treating this as a pilot study. It does look at least possible that the percentage diagnosed at stage 1, for example, tends to be lower if they're rural and remote than if for those that's diagnosed as stage 3. In other words, excuse me. So, well, if we look at the data, it's fundamentally awful, but we'll get into the gruesome details about that. The first thing to notice is basically, I mean, it's really easy to understand the data in this form. So you can see why people might want to present it this way. But what we've got is 3 separate tables, one for those diagnosed at stage 1, one for those diagnosed at stage 2, and one for those diagnosed in stage 3. Now, no statistical software that I've ever come across is going to be able to read the data in this form. So you might still want to keep a copy that looks something like this, but you'll also need a substantially modified version of this data in order to analyse it properly. So what changes are we going to have to make? We'll have a look first at what structural changes to the data set we need to make. If you've actually looked at the contents of this data set, you may also notice that there are some seriously obvious data errors in there, but we'll come to that in a minute. Okay, structural changes. So how does it need to look for a statistical package to be happy with it? First of all, every statistical package that you might use, or that I've seen in the last decade or so, is going to require the data in the form of a rectangular matrix with cases as rows and with attributes of those cases as columns. And that's the core structure that you want. The thing about having a data for analysis, you need that rectangular matrix, and you absolutely need nothing else. In fact, you can't have anything else. So the first thing that's got to go is these boxes at the side, because fundamentally that's just going to confuse the statistical software completely. So that's got to go. The second thing is that rectangular matrix needs to have a single heading row. So we could think of this, and that heading row has got to have the column names attached to it, or as part of it. So in this case, we've got that list of names, but we haven't got it once. We've got it 3 times. So that's got to go. Then the second thing is that the titles in this case they're not horribly bad, but they're too long. I mean, fundamentally, once you start analysing this data, the outputs from the analysis are going to use the column names as ways to identify bits of the analysis. If those names are too long, it's just going to make a hideous mess of what the output looks like. So we're going to have a shorter version of those names that we can refer back to. The next thing is that there are headings that we can't use at all. So we've got a super heading which says effects on stage of diagnosis. That's going to have to go. We can't keep that. Similarly, these table headers, diagnosis at stage 1, stage 2, stage 3, they're going to have to go too, because that's getting in the way of having this rectangular matrix with nothing but the individual patients and the column headings. So that's going to have to go. The other thing is you do not want any blank columns and you don't want any blank rows. So these, even when you get rid of those two, you need to get rid of columns A and B because there is no data in them. They're just part of something that made the data in this form easier to interpret, but it is not going to help. There are some things that this data set is okay about. Free text columns are the bane of any analyst's life, but this doesn't have any. So there is a tendency to have columns which is just for if you like, comments on each patient. And that's fine, but not in a data set that you're going to give to a statistical package. So that's not here. The other kind of problem that I haven't included, or there are 2 other kinds of problems that I haven't included in this. There aren't any missing values in this data set. When there are missing values, there is a historical tendency which goes back decades now to choose a number or something which means missing. Like put in a 99 if you want that to be read as missing. Well, the problem is 99 is a number and some of these are numbers too. So you really, really don't want to do that. There are different statistical software has different ways of handling missing data, but in general, the safest thing is to leave, if there is a missing value, to leave that cell completely blank. That doesn't mean put in a space, because again, statistical software will read a space as a text character. So that means absolutely empty, not anything else. Then anybody who is going to analyze that will find it easy to adjust the missing value arrangements to whatever the statistical package needs. So it's better not to put anything when you have a missing value. The other error that's not there is a serious temptation to put more than one kind of information in a column. So if, for example, one of the attributes was that you wanted was whether or not the patient was Indigenous, for example, you might be tempted to put in the gender column, instead of just female, make it gender / indigeneity, and put Indigenous female or non-Indigenous male or whatever. Don't do it. I mean, have it. If you need an extra piece of information in the data set, it's going to need to be a separate column. Okay, one final thing that's a problem with this data set is that our key response variable, which is whether they're rural or remote, is actually not there at all, because we've done that in this table by color coding it and with a heading of each table set. So when we adjust the data for analysis, as well as all the things we talked about so far, we're going to need another data row for whether the patient is from a whether the patient was diagnosed at stage 1 or stage 2 or stage 3. Okay, let's have a gasping pause at this point. And is there any queries about any of that? No, all good. Okay, so let's now look at the next stage of what happens when we do fix what are fundamentally structural problems with this data set. Okay, so this has now done all of the things I mentioned, and it's done it via, first of all, generating a new row of column headings, which are much shorter. So it's good to keep those definitely less than 12 characters, and I personally try and make them shorter than that. Then what's been done here is just a copy and paste of each data block in the previous table. So I've just copy and pasted the data for those diagnosed at stage 1, those in stage 2, those in stage 3. Because this is Excel, it's copied the color as well as the outlines, which the statistical software is not going to care about at all, but you get rid of it if you want to. But so that's now fundamentally fine. And I've added a variable to look at the stage, and essentially that was easy to fill in, though there are many errors in it, because they were all 1 or 2 or 3 in the color code, and we just added 1, 2, or 3 to be each stage. Okay, so at that point, the structure is okay. I mean, I can actually load that into a statistical package, and it's going to make unpleasant noises at me, but fundamentally it will read it, and it will read whatever you put in. There is one, and at this point we're ready to look at whether the data itself has errors, which it definitely does. There is one residual issue though. One of the things about Excel is that you can do calculations to generate new variables, and that's in fact what happened with the BMI. So people have calculated, this column has been calculated from the values of height and weight. And in fact, the screenshot that I put up here, so that first value of BMI has its formula, if you like, showing on the entry thing, and so it's basically saying this is calculated as the weight, which is cell C2, divided by the height in meters. So that's, since the height is here in centimeters, that's D2 over 100 squared. So C2 over so that's weight over height squared. And then that's been copied all the way down. Now, some statistical software, in fact, I think these days probably most statistical software will cope with that. In other words, what you're seeing is not really what's there. It's the outcome of what's there. But what you want the statistical software to read is the actual number, not the machinery to get there. Now, in this case, as I said, most statistical software is used to doing that translation, but not every software you might use. So it's safer to convert that to just a number before you feed it to the statistical software. One easy way to do that is to convert, excuse me, the data set itself, is to resave the data as what's called a comma-separated variable file, .csv. So what that does is basically one thing it does is convert all the formulas to the numbers and just keep that. But the other thing that it's very handy about doing is that if there are invisible bits in the Excel, they'll either get fixed or they'll get shown. So, for example, the way you get to make sure that what you see is what you get is to save it as a CSV file, and I'll show you how to do that in a minute. As I said, this is just an example of many of the things that you can have in an Excel spreadsheet where what you see is not what you actually get. For example, quite often there are ways to hide columns or rows in an Excel spreadsheet, and people often do that. And they quite often, for example, hide values which have been, it's decided that they should not be included in the data set analysed. They're basically, for some reason, they're outside the criteria that was used to select the data. You might have said, for example, that you are only going to include patients between ages 40 and 90, and you, by mistake, there was a 33-year-old included there or a 94-year-old, and so that gets hidden. The problem is when the data set is picked up by statistical software, it will read the hidden rows and it won't care. I mean, in other words, hidden rows are not hidden when you turn the data into something else. So converting it to a CSV file will expose pretty much all of that. It will fix the BMI formula issue, but most of the things that you can't see will become visible if you save it as a CSV. So the way you do that is essentially in the Excel spreadsheet, you go File, Save As, and then it'll give you a list of possible things that you could save the file as. And the one that you choose is CSV, comma, delimited, and it's blah, 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 when you're choosing what type to save it as. You may find, I might add, when you do that to a data set, that some of the errors which are not at all obvious in this data set become blindingly obvious when you do it when you save it as a CSV file. So it's not a bad thing to check with anyone. Okay, so when you do all that, when you do all those fixes we talked about, this is what you end up with. I've got rid of the color schemes because it's not that I don't like the color schemes, but we don't need them, so we'll just leave them out. Now, in terms of its structure, this is now absolutely fine. But in terms of its content, it is profoundly not fine. There are data entries absolutely everywhere in this data set. And as I mentioned, most of them are not going to bother a human being who scans that data. So if we run down the is rural remote column, for example, and we want, yes, they're rural remote or no, they're not, I know that a capital N and a small n both mean no, but statistical software is not going to know that. It is going to treat those two things as completely different levels of that variable. So, and let me just illustrate that. So, what I've done is I have fed this data set exactly as it is into a statistical package called R, which is which is my default package that I use all the time. And then what I've done is asked it to produce separate frequency tables for gender, stage, and rural and remote. In other words, to count up the number of values at each level for that. And I've also asked it to calculate the average age of the whole data set. So what do we do? What do we get if we give the software this data set and ask for that in its present form? Well, first of all, we'll get the stage frequencies, and instead of 1, 2, and 3, we've got 5 different categories, and this is not helpful. We've got equally 5 different gender frequencies. You'll notice some of the differences are obvious, and some of them are annoyingly subtle. So, for example, we've got a lowercase f and an uppercase f. We've got 3 lots of m's, one lowercase, one uppercase, and one that's actually been typed in as M space, and that's read as a different category. Some statistical software will let you insist on let you throw away leading or trailing spaces automatically, but a lot won't. So you need to know whether it's there. And similarly for the rural remote frequencies, I've managed to generate 7 different categories for that. Again, by a combination of upper and lowercase variables, the odd space in the wrong place, and in one case, typing yes instead of the Y that it was meant to be. So then when we tried to calculate the average age, it basically just said go away. And the reason it said go away is that it didn't read that as a number. It didn't read the values of age as numbers. And the reason is, if you run down that column, you see that there are 2 values which say greater than 80, which means you're using something which is not itself. You've turned that into a category. And so what you've sort of asked it to do is to read 2 different kinds of data in the same column. So it's chosen the one which is most generalizable, which is a category. So it's converted everything in here into categories and then said, well, these aren't numbers at all. I can't calculate a mean for that. So fundamentally, these are all really easy errors to make on data entry, and every single one of them is going to kill you if you don't fix it. All right. You may think that I'm exaggerating here, and people just wouldn't record data sets with this kind of category error in it, for example. Well, let me tell you, I am not. It is unusual for me to get data sets which don't have at least some of these. I think the worst one I've ever seen was actually right when we started running TARC, providing statistical help by TARC. And I won't embarrass anybody by giving the names of it, but it was a psychiatrist. And who sent me a data set which had about 400 patients in it, and each patient was supposed to have been diagnosed with one of 4 related disorders. And I just innocently read them all in, and there were actually, I think, 26 different categories for the disorder. And they were things like, there was a capital, sometimes they were abbreviated slightly, sometimes they'd been spelt wrong, sometimes, I mean, there were, so that's got to be fixed. Now, the thing is that if you have to do this manually, it can take a very, very, very long time. But giving due credit to Excel, the people who produced Excel were very conscious of this sort of error, which Excel in a way facilitates because it'll accept anything. And so they've included all kinds of things to help avoid it. And using the techniques that they've included can save you immense amounts of time, in fact. But surprisingly few people know what's available to use, or let alone how to actually use it. So that's what I'm going to show you at this point. So we'll use this same data set to look at ways to actually fix that data. So in order to do this most easily, we're going to use 3 spreadsheets instead of just one. The first one is going to be the data itself, which is just what we've got here. Then we're going to have a code book which basically translates each variable name, and this is really something that lets you keep the long names that you probably want to call everything. Keep a record of that, but not in the data set itself. So you're going to have so that's going to be essentially a list of the column abbreviated names with a translation of what that actually means. And then the third sheet is going to be a sheet which actually specifies what values each variable should take. Now, some people will combine these two, the code book and the variable into a single thing. That's perfectly fine too. To use it for the kind of correction technique that I'm going to show you, it's a little simpler to have a separate sheet for the values, but it's not essential. So what that's going to look like, so you'll have you'll notice that on the left here we've now got we've got the data set itself on the right, and we've got 3 spreadsheets now in this whole data set. One is the data itself. One is this code book, which is just a list of the abbreviations and a translation of what they mean. And the third one, which you can't actually read, says levels, and that's going to give us the levels of each data set. So the levels one is going to look like this. So we've got ID values, which I'm not going to fiddle with, but we had 24 patients, and they've just been labelled 1 to 24. The gender, we just want to have 2 options, male and female. We want to make sure that there aren't any impossible weights and heights in there. So we're going to say, okay, we're going to have a weight around weights need to be between, say, 50 and 120. Heights need to be between 150 centimetres, 200. We're going to specify an age range. We're going to specify a BMI range, and we're going to specify the values that these can take as well. So rural, remote can be no or yes, and the stages can be just 1, 2, 3. Okay, now what we're going to use is a very I think it's only been in Excel for about 10 or 15 years, which may seem like a long time, but Excel has now been around for about 40 or 50 years. So it's relatively recent. So what I'm going to do is move to Excel and show you how it works. But I'll first of all give you a kind of outline of what it's doing so that you can see it. Oh, is that a query from Kate?
Yes, it is, Rhonda. Why did you choose to use Roman numerals for the stage rather than
just to be
no
irritable,
no,
right? I mean, you don't have to. I mean, so
no,
we could convert everything here to just 1, 2, 3.
Yep.
And it would be equally fine. But the point really is that it doesn't matter in a way, as long as you're consistent. When you actually analyze this, if we called it just ordinary numbers 1, 2, 3, then I'd want to turn that into a category anyway, because I don't want it to start doing arithmetic on the stages.
Yep.
I want it to be categories, but any statistical software will let you have as categories either something like this, which isn't numbers at all, or you can turn numbers into categories if you want. But the important thing is to make sure it's consistent. Is that all right?
Yes, fabulous. Thanks.
Okay. All right. So how are we going to do this? And so I'll show you, if you like, the recipe, and then we'll actually do it so that you can see how it works. Okay. So this is the recipe. So what you do is there's one of the tabs in Excel is labeled data, and it lets you do all kinds of things with data, and looking for errors is one of them. So you'd select the column in the data spreadsheet where you intend to fix the errors, and say we want to fix the stage variable to start with. Then you'd go to that data tab, and under the data tab you'd pick a thing called data validation. One of the things that does irritate me slightly about this in Excel is that instead of calling it data validation, it's got a little picture thing, which, I mean, how you meant to know that little picture means data validation escapes me totally. But if you run the pointer over it, it says what it is anyway. When you hit that data validation option, what it sends up is this little box to fill in. And so in this case, and there are options there. So under the allow thing, first of all, you'll notice it's left open the option to change this, to modify this, but it hasn't left open the option of specifying that the data lies between, say, 50 and 100, which you also can do. And that's because it's already noticed that stage is not a number. So it's being smart about it. So when we look at this, there's multiple options under what you can allow, and we'll choose a list of values. And then in the source column, you click it to say you're going to use the source. Then you go back to the spreadsheet, to the levels spreadsheet, which and select the 3 values of stage. Then you just paste it in there and click OK. And at that point, you're set up to do either corrections or data entry, which prevents errors. So what we might do now, and the other thing, if you're doing it to an existing data set, you can also then say, and show me which values there are problems with, which is also very handy. Okay, so what we'll do now is get rid of this and go to Excel itself and have a look at that. Okay, so is everybody getting the actual
Absolutely.
data set now?
Yep, perfect.
Okay. Whoops. All right, so so what we'll do is go through that process with stage. So what I'm going to do is select the column for stage. Then I'm going to look for, so it's the data tools thing. I'd forgotten that. So this varies depending on the version that you've got, but it'll either be called just data or data tools. Now, the one we want is that one. And as I said, the little picture that is no help at all in finding what you want, but nonetheless it's there. And so, and what it says is, okay, data validation, it'll let you pick from a list of rules to limit the kind of data that can be in a particular cell. Okay, so we click that and we get the data validation option, right? Now, at this point, it says, what's in here, it says, let any value be possible. But we don't want that. We want a restricted list. So that, if we click that, I mean, there is a whole set of things that you can decide it to be. One of the, and they'll each have formats which you can provide. In this case, we want to give it a list of possible values and make sure that we're only going to have those. So we'll click list. Okay, now we're going to go back and decide what the list is. So we click on source. And at that point, go back to that levels spreadsheet. That again. So at this point, these are the levels we want to allow, and we don't want to allow anything else. So basically, we select those, they're now, they go straight to the validation box. So at that point, we can just say, okay, that's what I want. All right, now so it's gone back to the data set. You'll notice that now there is this little arrow thing on the side there. I selected stage as well, so it's pickily saying, well, this isn't a 1 or a 2 or a 3. So, but we're going to ignore that. But you'll notice it does the same thing whenever we click one of the values. So at that point, if you want to, it gives you the options and you just have to click one to enter it. So we'll do that to demonstrate. So basically this was a 1 and it should be the capital I. So we'll change that to 1. Now, but it would be obviously easier if we didn't have to scan down and see what the errors were. So we want to make it obvious what the errors are. So at this point, we go back to the validation box and say, okay, put a circle around the invalid data. And at that point, it needs to think for a while. And basically, it's just done that. So at that point, you've got, it's again saying, this isn't one of those, but you can ignore it since that's the heading. It's not identifying this one because we've already fixed it, but all of the other errors have now got red circles around them, which makes it very simple to go through and say, okay, yeah, fix that, fix that, fix that, fix that. Okay. And then if we ask for the circles again, it'll, with a bit of luck, they'll go away. And at that point, only stage is left. And so now it's saying everything in this data set is one of those permitted values, and there is nothing else. Okay. So is everybody comfortable with that? It's a really, really nice technique. And as I said, hardly anybody knows it's there. And so this can save hours if you've got a data set with 500 values and you need to find where the problems are and fix them. Okay, what you can also do is the same thing for when you're filling in the data sheet in the first place. So I won't do that from scratch, but here what I've done is actually done that specification of what is possible before any of the data has gone in. All right. So when I hit stage, or any value of stage, or so let's start rural remote. So I've done the same thing for every variable. And it says, okay, here, this column only allows no and yes. So if that's a yes, I've got to click that. With the BMIs, well, we'll put in a stage as well for the hell of it. For the BMIs, what I've done is told it that the range of values, I've told it that this is a number, that it's a whole number. So it's a number. Or did I do it with BMIs? I'm not sure I did. Let's stick with age instead. I've told it what the age range can be, what the minimum age should be, and what the maximum age should be. So if I then stupidly put in, which was 40 to 90, if I stupidly put in something which isn't that and try to enter it, it tells me that the value doesn't match the data validation restrictions that were defined for this variable. And that means it's essentially stopping you doing a bad entry before it even gets started. So at that point, you could just cancel it and put in something that does work, which might be 45, and it's fine. And similarly with gender, that's been turned into a point and click. So this again is really very handy for if you're having to do manual data entry, and you want to do it with as few errors as you possibly can. This is going to at least get rid of the really obvious big mistakes. Okay, so are there any queries about that? It's a startlingly easy function to use, and as I said, I haven't come across anybody who actually knows it's there. So very handy. Yep, Catherine.
Hi, I was just going to say that I'm just thinking about filtering in the old data set when you've been gifted a whole spreadsheet to formulate into some magic work. Is there any other way to sort of do a find and filter in the column that you've got in a sort, so that way you can do a batch like correction once you've done your data? Because I use data tools or the data validation a lot.
Okay,
so
yes.
yeah, once you remember how to do it, it's great. But I'm just thinking, like, when you've got like 500 zillion entries, you know, individually going down with the circles might not be easy, but if you can find the common problems like N instead of a capital N and Y
Yes,
instead of
that's right.
yeah.
You can sort on these values if you can sort the whole data set on those values if you want.
Yeah.
And get them all in one place and fix them all at once. That's right.
Yeah, perfect. That's what I was thinking.
Yeah. Okay. Any other queries about that? So you have found this before, Catherine?
Yeah, I had someone show me about a couple of years ago, and once you know about it, you think it's the best thing since.
Absolutely.
Sliced bread.
That's right. You are the first person I've come across who knows it's there. So that's, which is just fascinating. Yeah, that's good. Okay. Any other queries about all that? Okay. Well, I mean, I think we've actually gone on a bit longer than I was supposed to, in any case, but I mean, I think this is probably the most useful of the Excel tricks in terms of minimizing errors on either on the way in or fixing the errors if you've got a data set where they're already there. But if there are other shortcuts in Excel as well, and if you have a specific problem that you have in the data set, it's worth checking. And as always with this sort of thing, Google is your absolutely best friend. So if you think there might be an operation in Excel which would help, actually Googling something like can I filter out asterisks in an Excel spreadsheet somebody almost certainly will have done that, and there will be something on Google to say how to do it if there's a method. The other thing about Excel is that they keep modifying what they offer. So it really is it's not what you would want to use to actually analyze the data, but it really is pretty good at fixing the data before you start to try and analyze it seriously.
Okay.
All right. Are there any general queries? And I'll stop sharing the screen at this point.
No, thanks. But that was really useful, Rhonda, particularly that absolute hack to clean the data. That's fabulous.
Yeah, it's very cute. It's very cute. Okay. Any queries about any of that?
Yeah, I've just got a query, Rhonda, and it's sort of I haven't done a lot of data analysis, but one thing that was kind of always said is do all your cleaning in your software, which is incredibly tedious, but it meant that you had a record of what you'd done. I would much prefer, this has been fabulous, I just like this functionality and all that, but do you have any thoughts or kind of
Yes, I do. In fact,
over
I should have said something about that. I mean, one of the things that it's also really important to do, because Excel doesn't keep records. That's absolutely right. So so one of the things you absolutely need to do in Excel is keep a separate spreadsheet that is effectively the history, or separate spreadsheets which give you the history of what you've modified. So, for example, I would keep this is the original reshuffle data set, but I would also keep the original horrible data set which you couldn't analyze at all. Then keep this one, which is the one that we fixed.
yeah.
Then keep a copy of the spreadsheet when you've done the variable by variable fixes, so that it's always possible if you think, oh no, I calculated BMI wrongly and to go back and not repeat the entire process, but just the step that was messed up. It's true that if you do the same thing in R, for example, you will have a history of everything you did, and you can just do the same thing again on the entire data set. But not many people are willing to learn R to do that for quite good reasons. So one of the minuses about Excel is that the keeping the history is something that you have to consciously do yourself. And I should have said that before, in fact.
Yeah. Thank you.
Any other queries about that? Okay.
No. Fantastic. Thank you very much.
You're very welcome. And so I think we're done. And thank you for coming. And I hope you enjoyed it.
Really
Great.
good.
Thanks so much, Rhonda. Thanks, Ray.
See you later, guys.
Thanks,
This will
Ray.
be up on the website early next week.
Thank you.
Bye. There we go.
I'll talk to you in a bit.
Pardon?
I'll talk to you in a bit. I'll come down.
Okay. I'll switch it off.